Hey guys, how's it going? My name is JP and welcome back to JP Math. Today we're going over algebra review again. This is the second video that I've created so far for algebra review covering linear equations. And this is going to be my last video covering linear equations before we go into quadratic equations. So in this video, we're essentially going to go over converting word problems into linear equations that we can solve with the same methods we did in the previous video. So without further ado, let's get into the first example. So in this example, we see a company has a total of $20,000 allocated for monthly costs. Fixed costs are $15,000 per month, and variable costs are $18.50 per unit. How many units, that's the big question right there, how many units can be manufactured in a month? So when I see how many units, that's what we're solving for, our units. So that's the variable we need to solve for. So we're going to make units equal to our variable x. So that we're going to be solving for x in this equation. So like most linear equations, you have a left-hand side equal to a right-hand side. Okay, just like that. Go back like that. So when you look at this question, again, let's start from the beginning. The company has a total of $20,000. When you see total, that means everything on one side of the equation has to be equal to $20,000. So you know one side of the equation is $20,000. So we'll go like this. Equals to your right-hand side, which we're going to find out momentarily. So for the right-hand side, you see your fixed costs are $15,000. So you know that's not going to be multiplied by anything. That's $15,000 flat. And next, we have to add the variable costs, which are $18.50 per unit x. So that's plus $18.50 multiplied per unit. So looking back at this, you can see $18.50 per unit plus your base cost of $15,000 is equal to your total of $20,000. So when you look at this, this is just a linear equation. So let's go ahead and solve for x. We'll first move that over 15,000. That'll just be 5,000 equals to 1850 multiplied by x. Now we solve for x, so we divide both sides by 1850. Those cancel. Right? And when you get this, you get 5,000 divided by 18.5. Again, I'm using a calculator to clarify that I'm not doing the correct answer or incorrect answer. And from here, you'll find that x equals 270.27 units. Now, it's important to note that this isn't actually your answer when you think about it, because how many units is they're asking about like a whole unit. Because when you think about it, like if you're going to buy a storage unit in the real world, you're not going to buy like a little corner of the storage unit, right? You're going to buy the entire thing. So that's basically what they're asking here. How many whole units will get you to $20,000, but you can't go over that price. So you'd have to actually round down, because if you went up to 271, you'd obviously go over your budget. So your x actually has to be 270 units. Okay, so if you guys have any questions about this or the next examples, just leave a comment down below and I can do my best to answer them. So moving on. Example 2, Christopher can paint the interior of his house in 15 hours. If he hires Cynthia to help him, together they can do the same job in 9 hours. If he lets Cynthia work alone, that's kind of a mean thing to do. How long will it take her to paint the interior of his house? So looking at this, there's an initial misconception where you say, all right, we have Chris right here, right? He paints in 15 hours by himself, right? And when you see Cynthia plus Chris, that equals 9 hours. So, someone would be like, oh, we can just plug in Chris right into this little equation we created and you can solve for Cynthia her time doing it by herself. Well, that's not how this is going to work. We actually have to solve this with a set of ratios. So I'm going to write it out really quick just so you can see it, and then I'll explain it a little bit. So Chris and Cynthia, their time combined is 9 hours, right? And when you divide that by Chris's total time, and if you add this fraction to this fraction here, that's going to be equal to 1, because when you add fractions together, you're going to get a whole number, and 1 is referencing to a completed paint job. So you have Chris and Cynthia divided by Chris plus Chris and Cynthia divided by the time it takes for Cynthia to finish is equal to 1. And this is kind of a weird problem because you wouldn't expect it to be set up like this, but you'll see that it ends up working out pretty well. So let's get into it. So Chris and Cynthia, we know theirs together is just 9 hours, and Chris by himself is 15 hours. Add that to Chris and Cynthia, which is just 9 hours again, over the time for Cynthia to complete hers, which we do not know, which is our unknown variable x. Yeah, we don't know that. And that's all equal to 1. And what do you know? You have a linear equation. So let's solve for x. We're going to do 9 over x minus 1 minus 9 over 15. That's just going to be equal to 6 over 15, if I did that correctly mentally. And we're going to essentially just move x over, so you have 9 equals 6 over 15 x, and then you just solve for x. So once you solve for x here, you will realize that x is equal to 22.5 hours, meaning that if Cynthia was to work alone for some odd reason, she'd take almost a full day. So Chris is an evil person if he makes Cynthia do this completely alone. I would not be friends with Chris. Moving on to example 3. This problem I put as the last question because this problem made me so angry when I was doing intermediate algebra, when I was first learning mathematics. And you'll see why. There's just a little bit of confusion that can go on here. So anyways, a motorboat can maintain a constant speed of 16 miles per hour relative to the water, meaning that without any current going on, the boat is going 16 miles per hour, not taking into account current. Just needs to be noted right there. So 16 miles an hour is constant. The boat makes a trip upstream to the marina in 20 minutes. The return trip takes 15 minutes. What is the speed of the current? So our unit that we need to solve for is speed. We'll just set speed equal to x like everything else. So let's take into account. So we're going to have a upstream equation and set it equal to our downstream equation because they have to be equal to each other in order for this statement to be valid. So let's look at our upstream case. Right. So when we look at this river, this is a very poorly drawn diagram here, but you have the river current, x, and you have your boat, your sailboat, going in the opposite direction, going at 16 miles per hour at a constant speed, right? So these two speeds are going in opposite directions to each other. So you have to take the difference between the two to relate them to each other. So that looks like 16 miles per hour, subtracting from the opposite direction that x is coming in, right? And you also have to take into account that it takes 20 minutes for this whole situation to happen, where you're going from point A to point B being the marina. So in order to do that, we actually have to multiply all of this relation that we created by 20 minutes. But not just 20 minutes. We have to actually multiply it by 1/3 hours because 20 minutes is just a third of an hour. And because we have hour units in miles per hour, we have to make sure we have consistent units. So that'll be our left-hand side of the equation. Now let's take a look at the downstream side. So in this case, we're on the way back from the marina. So we have point B here, for example, and point A. You have your current going in this direction, going x, and you have your boat right here, going at 16 miles per hour in that direction. So you'll notice that the boat speed and the current speed are in the same direction. So that means they will actually add to each other as opposed to the other situation. So 16 miles per hour plus the speed of the current is going to give you a relationship for the current speed in this problem. So then we also need to take into account it takes 15 minutes on the way back because with the current. So we're going to actually multiply this by 15 minutes or 1/4 hours. Now we have a left side and a right side to the equation. Now we can set them equal to each other because you know they have to be equal for this statement to be valid. So I'm going to rewrite this without the units in because we actually already know what the units are. We've stated they're correct. So that'll be 16 minus x equals 1/4 times 16 plus x. Okay, so now this is a linear equation. We can solve this very easily with the methods we used in the first video. So I am personally going to just multiply through each of these little 1/4 and 1/3 to the parentheses to simplify it. So that will just be 16 over 3 minus x over 3 equals 4 plus x over 4. So we're going to move this to this side, and that'll be 16 over 3 minus 4. I'm going to use my calculator for that to make sure I don't make any simple math errors, which we want to avoid at all costs. That is going to be equal to 4 over 3 minus x over 3 equals x over 4. Let's move our x's to the same side. So you have 4 over 3 equals x over 4 minus x over 3. Let's quickly plug that in. So that would be 1 over 4. Actually, it should be plus 1 over 3. My apologies. And that's going to be equal to 7 over 12. Or you could just call it 7x over 12. So now you can very easily solve for the unknown variable x. And when you do that, you get that x is equal to, let's double check this really quick, 4 over 3 times 12 over 7. Or you could do divided by 7 over 12, same thing. And you get 16 over 7, which is essentially equal to 2.2857 miles per hour. Okay, so it's going to take the current speed we decided in the river is going to be equal to 2.2857 miles per hour. So again, this equation is tricky because you have to take into account the direction of current and the direction of the boat to come up with your left-hand side and right-hand side of the equation. So I struggled with this a lot, and I hope you guys understand this a little bit. But anyways, that is going to conclude our linear equations 2 video. If you have any questions regarding the problems done here or would like some assistance on any problems, please leave a comment down below. With that being said, thank you all for watching, and yeah, I'll see you guys in the next video.